An archer shoots an arrow. The height h meters of the arrow above the ground is modelled by the formula h equals 1.8 plus 0.4d minus 0.002d squared, where d is greater than or equal to 0, and it is the horizontal distance of the arrow from the archer measured in meters. So this is the horizontal distance that the arrow has travelled, and this is the height above the ground. So basically this is a modelling with quadratics. As it moves in the horizontal direction d, it has a height h, and the quadratic is going to look something like this. This is the way the arrow is being fired. Right, so the question says, finds the horizontal distance travelled by the arrow as given by this model. Well, it's going to keep travelling until it hits the ground. So until h is equal to 0. So if I make my equation equal to 0, this is going to tell me the value of d when the height above the ground is 0. So 1.8 plus 0.4d minus 0.002d squared is equal to 0. Now, the question doesn't say we can't use calculator method, so you could use your calculator to solve this. I don't think it's going to factorise very nicely, so that method is out. We could use the quadratic formula as well if you wished. We could use the quadratic formula with a being minus 0.002, with the b being 0.4, and with the c being 1.8. So we could substitute those into the quadratic formula, like I say, which would be, let me just remind you of the quadratic formula, b minus b plus or minus the square root of b squared minus 4ac divided by 2a. So we would have minus 0.4 plus or minus the square root of 0.4 squared minus 4 times 0. Running out of space here, I really should have written a bit smaller. So minus 0.4 plus or minus the square root of 0.4 squared minus 4 times minus 0.002 times 1.8, all divided by 2 times minus 0.002. And if you substitute that into your calculator, you'll get two answers. One of them will be negative, which we don't want. We're not going to fire the arrow in a negative direction. The positive one will be 204 units in meters. Like I say, if you've got familiar with using the equation solver on your calculator, you could have used that at this stage. You don't have to use the quadratic formula. So that's part A. Key thing there is the height is 0 when the arrow lands. Therefore, we make the equation equal to 0 and solve it. Part B. With reference to the model, so with reference to the equation, interpret the significance of the constant 1.8. So what does this represent? Well, this represents the height, h, when these are 0, when the horizontal distance is 0, because I would have h equals 1.8 plus 0.4 times 0 minus 0.002 times 0 squared. So if the horizontal distance is 0, then the height is 1.8. So what that's saying is that 1.8 is the height that the arrow was fired from. So 1.8 is the height above ground when D equals 0 or when the arrow was fired. You could also say it was the height of the archer, maybe. Okay, part C. We need to write our model in the form of a minus b bracket d minus c all squared, where a, b and c are constants to be found. So this is saying to complete the square, basically. This is completing the square format. Now, in order to complete the square on this, I'm first going to rewrite it so I have the quadratic squared bit at the front. So minus 0.02d squared plus 0.4d plus 1.8. Now, to complete the square, I can't have this minus 0.002 at the front. So I'm going to factorise that outside. So no completing the square yet, we're just factorising to begin with. So taking that outside, we will have just a d squared at the front. Because when I take this and divide it by the minus 0.002, it just leaves me with the d squared. Hopefully it's pretty clear that this times this is this. Right, what about this? Well, if I divide that by the minus 0.002, you might need to do that on your calculator. 0.4 divided by minus 0.002 gives minus 200. So we've factorised. This times this is this. This times this is this. Right, now we've factorised, we can get on with completing the square. Notice I didn't do anything with the 1.8. We'll just leave that on the end. That's easier. And we'll deal with that in a minute. Right, let's factorise on the, let's do completing the square. So we're going to half the 200, which is 100. And we're going to take away 100 squared, which is 10,000. Now we're going to multiply back out. So this times this. And then this times this. So that's going to give 20. Not forgetting the plus 1.8 on the end there, which we can then add those two terms together to be 21.8. And there we go. So just comparing this to the model, to how it's told us to write it, the A is 21.8. The B here is the 0.002, and the C here is the 100. If you wanted to, you could rewrite this as with the 21.8 at the front, just so it matches up perfectly with how they've told us to write it, but you don't need to. It was fine how we wrote it, but you could write it like that if you'd prefer. Right, so let's just remember what that's actually, before we carry on with the rest of the question, let's just remind ourselves what this says, because it will be helpful. The completing the square format is telling us that the maximum height is 21.8 metres when the horizontal distance is 100. So when the arrow has travelled 100 metres in the horizontal direction, it will be 21.8 metres above the ground, and that is the maximum height it's going to get to. That's what that is saying. Right, let's carry on with the rest of the question. It's decided that the model should be adapted for a different archer. The adapted formula for this archer is h equals 2.1 plus 0.4d minus 0.002d squared. Right, let's compare that to the previous one. So this is a new archer. This was the old archer. Now, the only difference there is this is a 2.1 instead of a 1.8. Everything else is the same. Now, remember that the 1.8 represented the vertical height from when the arrow was being fired. So the fact that this is 2.1, that just means that it's being fired from a slightly different height. It's being fired 0.3 metres higher above the ground, or 30 centimetres higher above the ground. So, because maybe this archer is taller. He might be just as good an archer, but he's just a little bit taller. That's basically what this is saying. It's being fired from just 30 centimetres higher. The fact that the rest of the model, the fact that the rest of this is the same, means that arrows are going to follow the same sort of trajectory, but this one will just be 30 centimetres higher. That's what this is saying. So, part D. Find the maximum height of the arrow above the ground. Well, we just found the maximum height for the first archer as being 21.8. So the maximum height of this archer's arrow will be 30 centimetres higher. So 30 centimetres higher will be 22.1 metres. And that's going to happen when d equals 100. Because, like I say, they're both following the same trajectory. So when we get to 100 metres, when the horizontal distance is 100 metres, that's the point where they will both have their same maximum height. It's just one will be 30 centimetres bigger than the other one because it started from 30 centimetres higher. So part D is really testing about whether you understand about the fact that these bits are the same, what that represents, and what this change here, what that represents.